The height of water in a bay varies sinusoidally over time, which means it follows the shape of a sine graph. And remember, sines and cosines are the same shape. On a certain day, a high tide of 4 meters occurs at 5 a.m. and a low tide of 1 meter occurs at 1 p.m. The next high tide being at 9 p.m. In other words, it's symmetrical. 5 a.m. to 1 p.m. is 8 hours, and 1 p.m. to 9 p.m. is 8 hours. So it's symmetrical over this 16-hour period. Find a model for the height of the water, h, over time t, where t is the time since 5 a.m. So we're going to take 5 a.m., that's the first high tide, as t equals 0. A boat cannot enter the bay if the water level is less than 2 meters. Between what times can it enter the bay? So the first thing we've got to do is find the model. So let's start with the graph. And we know that the high tide is 4, the low tide is 1, and we've got the 16-hour period here. So 5 a.m. would be here. So we know that we had a high tide there. We know there was a low tide after 8 hours, and the next high tide was here. Now, it's a sine or cosine graph, so we know the symmetries. So halfway between 1 and 4 is 2.5. It's going to have a midline here. And after 4 hours, that's halfway between the high and low tide, it's going to be in the middle. And on the way back, it will be in the middle again. Once we've got that, we know the shape of a sine graph or a cosine graph. So we can fit that to what we've drawn so far. So what we're wanting is to find the equation of this curve. Since we start with a maximum at t equals 0, it makes sense to start our model with a cosine. So h is going to be a cos bt plus c plus d. And we know that these are the various transformations. So vertical dilation, horizontal translation, and vertical translation. And what we need to do is establish the values of a, b, c, and d. Starting with a maximum means c equals 0. The standard cosine starts with a maximum as well. So we've got to here. Had we started with a sine, so had we decided that we were going to use sine instead of a cos, then c would have been pi by 2. That's just to move the graph so that we have a maximum at t equals 0. But let's stick with the cosine. We can see that that midline for the graph is at 2.5. The midline is normally on the axis, and therefore that means that d is 2.5. So we now have h is a cos bt plus 2.5. We can see the amplitude here is 1.5, and that tells us a is 1.5. Remember, the amplitude on the standard graph is 1. So we've now got to here. We just need to work out the b. That's usually the most difficult bit, but we'll look at that next. The period of the cosine curve is normally 2 pi, but we need the period to be 16. Remember, it completes that complete wave in 16 hours. So what we need is for b times t to be equal to 2 pi when t is 16. So in other words, 16b is equal to 2 pi. Therefore, b is 2 pi divided by 16, or pi by 8. So now we have our complete model. H is 1.5 cos pi t over 8 plus 2.5. So we can start looking at part B. We now want where h is less than 2. Remember, when h is less than 2, the boat can't enter the bay. So we'll start by considering where h is equal to 2. So we've got 1.5 cos pi t over 8 plus 2.5 equals 2. Subtract 2.5 from both sides and divide both sides by 1.5. And so we have cos pi t over 8 is equal to negative a third. And remember here, we need to be working in radians. Now, the inverse cosine of negative 1/3, if we work in radians, is 1.9106. So pi t over 8 is 1.9106. So that's going to be here. And I know that just because the cosine is negative 1/3. So that means the principal value is in the S quadrant. I don't necessarily know 1.9106 is in that quadrant straight away. So that's that angle there. And remember, it's a cosine, so the other one will be symmetrically down here in the T quadrant. And so the other possible value is 2 pi take away 1.9106. Remember, 2 pi is all the way around, and we got there 1.9106 before 2 pi. So pi t over 8 is 1.9106, or 4.3726. Multiplying both sides by 8 gives us this, and then dividing by pi gives us this. And of course, these times are in hours. So let's work with those. Remember, this is after 5 a.m. So whatever these are, we're going to have to add the 5 to them to get to our final answers for times. Ignore the 4. 0.865 times 60, so we're finding the number of minutes here. That's 51.9. So that's 4 hours and 52 minutes after 5 a.m. Remember, 4 hours, and the 0.865 hours is 52 minutes. So that makes it 9:52. Now let's do the same thing with the other time. Take off the 11, and 0.135 times 60 gives us 8.1 minutes. So that's going to be 11 hours and 8 minutes after 5 a.m., which is at 4:08 p.m. So that means that the boat can't enter between 9:52 a.m. and 4:08 p.m.